let's start the lecture today. Welcome to the class. Welcome to today's course. Today we will follow on the topics we discussed in the previous lectures, and we will enter today a new topic that we will discuss, which is the topic of network virtualization. So in this class we will learn about network virtualization, and specifically we will do three things. In the beginning we will start and we will discuss different types of network virtualization that are possible, different forms of network virtualization. With the goal of getting a better understanding of what network virtualization means. After we see, I think, 4 or 5 different types of technologies that we can consider them network virtualization technologies. Afterwards, we will focus specifically on 2 types of network virtualization. The one is data center network virtualization, where we will see how presently network virtualization is used in data centers, in multi-tenant environments, in modern data centers, and what needs it covers, and also some of the basic technologies that are used there. So this relates also a bit to the exercise that you have right now, the second exercise. Okay, so this will be one topic. As a side product of this topic, we will also watch a short video, as well as we will do a PI, a peer instruction exercise together to discuss what are the benefits of network virtualization and why it has become a popular topic in the last few years in the area of computer networks and is widely adopted today. And finally, at the end of the lecture, we will see, we will go past data center network virtualization, and we will see another type of network virtualization that is more common in campus and enterprise networks. And this type of network virtualization is also referred to sometimes as slicing. That we slice the network into slices. And this slice is a separate virtual network. And we will discuss some of the motivating examples there, and as well as some of the ongoing work. Okay, so let's start a little bit with the very basics. Of course, you all know what is a virtual operating system. Okay. In a virtual operating system, instead of having an operating system that runs directly on top of the hardware, in this case, we insert a hypervisor between the operating system and the hardware, and therefore, in the same hardware, we can have over the hypervisor here, we could have multiple operating systems running on top of the same hardware, and in addition to that, we could of course take this operating system and move it to a different hardware without any changes in the configuration and so on, and press play and launch our operating system in a different environment. Okay, so this is called operating system virtualization or host virtualization, and I'm sure there are other terms out there. And this is something that in the last decade is something that has become extremely popular. So how many of you are using virtual machines? Pretty much everybody, so I'm the only one who doesn't use. I run on bare metal. Okay, so VMware did a survey like a few years ago, and they asked the question, what percentage of your servers run virtual machines? Okay, they operate on virtual machines. And this was directed to enterprise networks, corporate clients, and things like that. Okay, so around 2010, 2012, what would be a guess? How many? Like it's all several years ago. Yes?
I would say 10%, 15%.
10%, 15%.
I believe it was high. It must be higher, about 40-50%, maybe even higher.
2010.
Yes.
In Michalis got closer. And yes, okay. So 2010 was 30%, and already in 2012 it got to 59%, and it was estimated that probably by today it should be, I would guess, 90% if this trend has continued. Okay, so virtualization technologies have become very popular. Cloud computing is tightly connected with virtualization, and as a natural consequence of virtualization technologies, also network virtualization has risen in the last decade. It started more experimentally as a research project by different academic institutions that studied this topic, but presently it is used in enterprise, in data center networks, and also in other contexts.
I think VMware was the one who bought the SDN concept for some $1 billion. I'm not sure.
Bravo, Sava, right. So precisely. So, and I will mention this today later on in the lecture. Okay, so now let's see some different types of network virtualization to get a better understanding by example of what network virtualization is. And let's start with perhaps the simple form of network virtualization. So if we have a virtual machine running in our network, then as you know, the virtual machine has, I think you all know that it has a hypervisor. And then on top of the hypervisor, we have different VMs. We have VM0, VM1, VM2, and so on. So in addition, we could have a service console that we use to configure the hypervisor and other systems. So now, inside our computer, when we use a virtual machine, we have this topology that you see here. So each virtual machine has a virtual network interface card which connects to the hypervisor. And the hypervisor has on each side multiple virtual interfaces that connect to the virtual machines, and it also has an interface that connects to the physical network interface card on the other side. So this hypervisor works exactly the same as a real hardware switch. It's exactly the same system, but it only runs in software instead of running in hardware. It even uses the same protocols so inside here we have a virtual switch, and this switch, remember the lectures that we did on switching. A switch has a switch table that it learns the MAC addresses. It's a learning switch. and so on. So this thing, so here is another picture of the hypervisor in the VM kernel. So this thing works almost exactly as a physical Ethernet switch. It's the same thing. It's a virtual switch inside the hypervisor. Okay, the key difference is that instead of having an ASIC, as we discussed, an application-specific integrated circuit that on hardware does the switching now happens on top of the CPU. Everything goes through the CPU. Remember, this is what we used to say the slow path in a previous lecture. And everything operates over a classical x86 CPU. Okay, so, sorry, before going further on, we see that this is a first type of network virtualization. Already within our computer, we have a virtual network. We have virtual interfaces, a virtual switch, and virtual switching that happens. And one could also, now usually we have just one switch, but in principle it would be possible to have multiple switches that operate in software exactly as real switches and could do more complicated stuff in theory. Okay, this is precisely like the way network virtualization is applied in data center networks today. They exploit a virtual switch that sits inside the hypervisor. And which is this virtual switch? How is it called? Can anyone take a guess, Alex?
Top of the rack switch.
That's a good guess, but that's not right. That's not right, no. You got close to it. Actually, let me tell you that you all have used it already, I think, in the first exercise this week. Open vSwitch, OVS. Right? You did use OVS.
Yes.
So OVS is the exact same switch that is used in big data centers today for doing network virtualizations, and it's today the first switch that sees that the virtual machine sees. Okay, so the second switch that we will go through, our package will go through, will be the top of the rack switch that Alex said. But this is a physical switch that sits on the rack. Before reaching the top of the rack, we will go through the virtual switch that sits already inside the system. Okay, I'll come back to Open vSwitch a little bit further on, but OVS is a big player. Right? It's the most popular today virtual switch. And it's useful to discuss a little bit its architecture a little bit more. Okay, so this is one type of network virtualization. Okay, so let's now see another type of network virtualization. And now let's forget the host. Let's forget the host and let's go to the real network. Okay, and let's see that we have here a campus of an enterprise. It has some routers, it has some switches, it has some firewalls, it has a bunch of stuff. It serves, I don't know, a few, like 1,000 clients. And so on. Okay, and let's assume that what you see here is the physical infrastructure that we own. Okay, Now, an enterprise, for a bunch of different reasons, it might want to create a virtual network on top of the physical infrastructure. So, for example, it might want to create one virtual network that is the network of the IT department that has some infrastructure here, some infrastructure there, and has virtual interconnections. And this could be also sometimes enterprise networks that are not into technology. For example, a company that is into a pharmaceutical business or medicine business and so on. They usually outsource. They hire a third party to manage their IT infrastructure. This is called IT outsourcing. So, I don't know, name a big Nestlé, for example. Nestlé could hire IBM to, let's say, an example, to manage its IT infrastructure. For the IT department that does the management, they might want to have an isolated network that is essentially a virtual network that sits on top of the physical network. Okay. Similarly, we could have other virtual networks. We could buy a smaller company, and we might want to merge the we might want to migrate the network of the smaller company, and so on. So another form of network virtualizations, it's also called slicing. This type of network virtualization is that on top of a physical network, we have slices of virtual networks that concurrently use the underlying physical networks. Now, I'm not going to discuss yet the technologies that we can use to do the slicing, but let me say at this point that we can use many different technologies to do slicing. Today we will see how you could do it with SDN, the slicing, and with a system that's called FlowVisor to do this slicing. But besides that, we could also use other technologies, more traditional technologies, even technologies that we know already, like VLANs, for example. Okay, and this takes me to the next topic, that there are also some traditional technologies that we know for many decades now, like VLANs, for example. VPNs is another technology. So what is the difference between a VLAN and a VPN? Who can tell me? Yes?
I'm not sure, but I think that VLAN is used to create a whole area of network, but VPN we can use it to connect μέσα από έναν άλλο through another third party. Yes.
Right. Yes. I think it's high level, but it's in the right direction. Anyone else that wants to help? Okay. So VLAN, remember, we talked about VLANs. It's like we have a switch, or we have multiple switches, a switch network. We have multiple switches interconnected, and on top of this, we might want to create some virtual LANs. Okay. And we want to separate hosts, like that hosts that sit in this port. They should be in the one VLAN, like. In the computer science department should be in a different VLAN than the medicine department, and so on. Okay, and we discussed in a lecture, in the second lecture, we discussed like when we have a switch and we can separate the ports of the switch and put them into different VLANs. So VLAN is a layer 2 technology and enables to create multiple LANs on top of a LAN. Okay, multiple virtual LANs on top of a LAN. And this is a form of network virtualization. Okay. So network virtualization has many different phases, and it's important to see this because to understand the diversity of network virtualization technologies and to be able to get into context when, if you happen to discuss this topic later on. Okay, so I explained VLAN, VPN. How many of you use a VPN? Okay, right. What is the VPN? Connect from home, right? This is what is a VPN. It creates again a sort of a virtual network where basically you are at home, but you have the virtual experience as if you are at the university. So this is what VPN does. Or if you go and work tomorrow, you could be again at home. That's the most common need it solves. And you connect through the virtual network to the network of your organization to access the servers, to access the file systems, and so on that are located there. Yes.
Without having any service provider. Let's say we haven't paid for our SITA.
You need to have a basic internet connectivity.
Okay.
And this works. It can work in different ways. The most common, the simplest way that we use is we have a software in our computer that establishes a tunnel with a server in the campus network of the university, and then basically from that point on, we are as if we were exactly inside the network of the university, as if we were here.
And we reach the maximum speed that
your provider.
No,
not the provider of the university.
No, in terms of speed, no, you cannot get the speed because you are limited by SITA or by that provider. But you have the access to the servers that the university can have servers here that are not open to the outside, and you do have such servers. So it's a matter of access to servers, printers, and things like that. Yes, Lefteri, please.
Talking about this, I was thinking that the VPN default in most operating systems, gateway is the place that the VPN server is. So if you leave it like it is, you go to university and your traffic goes through the university to everywhere else.
Okay.
And if you are, let's say, in Ghazi, for example, you do this. You come here and then you go out.
Okay.
So the best way to do the VPN is remember that then you must use your VPN connection not to take this path to go everywhere because it's more hops. That's one thing. And the other thing is that VPN technology is so mature and so been a long time in the industry that it's very common for us to use. And many people have VPN connections to their homes. So one good exercise for you guys to do is install a VPN server at home and do that for your home. Because it's interesting, useful, and you can use your computer from everywhere and you can learn stuff at the same time. So whenever you have time, try it out. It's not difficult.
Okay. And then even classical, peer-to-peer networks like Skype, BitTorrent, things like that. This also, they built a virtual network on top of the application level 5, and one could also consider this as virtual networks. Okay. However, I want to stress that what we mean today, over the last few years, that it has become a hot topic by network virtualization, it refers to the topics we will see in the remaining of the lecture, and not that much to this classical, traditional forms of virtualization. These technologies can be useful and can be used in implementing modern virtual networks. However, the meaning of a virtual network has taken a new form the last few years. Okay, and finally, another form of network virtualization is the following. imagine that we have an actual physical network with the 3 switches we see here. One would like, for example, to hide the details of the physical networks from an application developer that wants to get some traffic from one rack in a data center to a different rack in a data center. Okay, to do this, to hide the details of the topology, we could provide a virtual view of the topology as one switch, as one big switch. Remember, sometimes we use the term switching fabric. Remember the term switching fabric, and this is used even for the entire topology of the data centers that could contain thousands of switches. We still call it the switching fabric. And sometimes it's easier to think of it, especially if we do some high-level application development, as a single switch. And we don't want to care about the details below. We want to hide the details by using abstractions. Okay. This is called, sometimes it's called the one big switch abstraction. And it's a quite common term in the area of network virtualization. So this is also a form of network virtualization, that we take, the big physical network, we hide it on top of an abstraction, and this abstraction is the one big switch. That's all I want to care about in the network. Yes?
If we want to discover the inner fabric, I think it's possible, but we imagined it as a single switch for simplicity, as I understand it.
No. I think probably you don't want to compromise the internal switches of your company.
I don't want to compromise. I want to learn.
That's the
how
thing.
My package
if
goes.
You want to learn, everyone would like to learn
Yes.
who serves you. Should this be happening?
Sorry, I'm got confused, guys. So let me try to answer this. This is useful when you don't want to know all the details.
Okay.
You don't need to know all the details of the topology for what you are doing. You might be interested in implementing a service like Google Docs or Google indexing, Google email, something like that. It's an application 5 service, and there the network should take care of load balancing and should be able to transfer large volumes of data, but you want to hide this from what you are doing, and you want to delegate this to the controller. This also relates with this layered view of SDN a bit, that the controller provides a network abstraction and hides the details of the abstraction. But we will come back to this also in the next lecture. So regarding this specific example, you don't need to understand everything today.
But let's assume that we have a problem in the one big switch, and we lose some packets, and we want to know where we lost them. We have to find how the big switch is
correct. You have. But who has to know
the administrator.
Does the email application need to know that?
No, the administrator of the network.
Right. So the administrator or the program that is responsible for troubleshooting. And
So the end user doesn't need to know anything, but the admins
They can.
can find.
Right.
Okay.
Okay, so that's enough. We already saw quite a few different types of or ways of network virtualization. So today we are going to cover the first two topics. These are, modern forms of network virtualization. The last one, I have some material. You can read it on your own. Most likely, we won't have time to cover it. It's just classical virtual private networks. And let's start with this. Okay, with this beautiful image. Okay, we don't need to read every detail here, but assume that this is a data center. This is the switching fabric of the data center. Here we have racks, On top of the rack, we have a top-of-the-rack switch, the Tor switch. Inside each physical host, we have the open vSwitch, the virtual switch. This is where the network starts today in the data centers, with this open vSwitch. Okay. This open, and of course we have multiple tenants that use this data center, and then we can have different types of hypervisors. And in the data center today, we have a controller. You can think it as an SDN controller that controls these open vSwitches. And let me start by saying that network virtualization in the data center is primarily driven by two needs. Okay, and when we are talking about network virtualization in data center, we have the following two needs. First is that different tenants be isolated the one from the other. Okay, here one tenant could be, let's say, Alpha Bank, and the other tenant could be Piraeus Bank, that are competitors, and they could have their private archives and secrets in the same virtual machine, sitting on the same host, even in an extreme case. Of course, they should be isolated, the different tenants, the one from the other. Okay, and they shouldn't see this entire network as a single layer 2 network. They should see it as a separate virtual networks. Okay. So network virtualization comes hand to hand with multi-tenant data centers, and it serves the purpose of isolating the one tenant from the other tenant in the data center. So this one is one of the drivers that has given birth to more widespread network virtualization in the recent years. And who can guess the other driver that is related, very related with what we discussed?
Maybe apart from the virtualization, you have to give the image of a whole network, like you are the only one who controls it. I'm not sure if that's it. But if you're inside the server, you have to believe, since you are a tenant, a client, that you are the only one who serves who is served by the client. By the server, I mean. It's not just a virtualization.
Yeah, so this is what I mean with the first part. Alex?
Maybe it's easier if you have big load to increase number of virtual machines. We can dynamically change the numbers of virtual machines.
Nice. This is what I want to hear. So in data centers we have two things: dynamic scaling, and also we have mobility in the data center. Like a virtual machine can move from one rack to a different rack. We pack them together. We shut down some racks to save energy, and so on. So we have lots of mobility in the data center. We could even move it. We have one data center in the east coast and another data center in the west coast of the United States, and we could move our virtual machines from one coast to the other coast. So we have high mobility. Because we have higher mobility, the network needs to be mobile, dynamic as well. It needs to adapt to these changes. And we have like separate networks for each tenant. Right. And this is a second driver for network virtualization. Okay, now before I move on, let's watch a video. So this is a video of how VMware, that I think it's one of the market leaders in this area, also in network virtualization, like pitches, like sales, their network virtualization solution. It's just 4 minutes, it's not too long. And remember that, as Sava said in the beginning, VMware this is related to SDN. VMware was the company that bought one of the first SDN startups from the guys that started OpenFlow for a crazy amount of money.
2.6 billion.
Yeah, I don't know. Okay. So let's see what can you do with it that worth so much.
Hi, I'm Raj. I work in IT for a company where innovation can't come fast enough. Last week, our CEO asks us point blank why it takes us so long to deliver services. Adam, our network engineer, starts explaining how provisioning network services is complicated stuff. We have to reconfigure switches, routers, firewalls. One mistake in a config file could affect everything. The boss asks if virtualization would help. I tell him, sure, it does. We can spin up virtual machines in seconds. And he says, no, I'm not talking server virtualization. I mean network virtualization. And he shows us an article on how eBay, AT&T, and Rackspace all reduced provisioning time literally from days to seconds. So he leaves, and Adam says, it's all you, virtual man. Just don't touch my network. Okay. I did a little homework and came upon VMware NSX. I installed the software and tested it out. The boss was right. I could spin up a network like I spin up a VM. It was easy. A couple of days later, I grabbed Adam to demonstrate. Check it out. Here, I add a couple of network segments, some VMs, drop a router in, apply a security profile, and bam, a complete multi-tier virtual network. I can save it, delete it, restore it, just like I do for VMs. He was stunned. He says, what do you mean by a virtual network, a VLAN? And I said, no, not a VLAN, a virtual network. It's just like a physical network, except the network is in software. Our applications don't see any difference. It works by distributing network software in hypervisors across the data center between the physical network and our applications.
Let me pause. This blue slice he just put in is Open vSwitch, basically. Okay. And
VLAN? And I said, no, not a VLAN, a virtual network. It's just like a physical network, except the network is in software. Our applications don't see any difference. It works by distributing network software in hypervisors across the data center between the physical network and our applications. Just think of it as a network hypervisor. I can connect physical servers or virtual machines to this virtual network that spans across physical subnets and availability zones to wherever compute capacity is available, in a single data center or several. So he just tells me I'm adding more complexity on top of everything his team already has to deal with. And I'm like, dude, I just provisioned a multi-tier network environment in 15 seconds. How's that add complexity? He tells me, no, you just drew a picture in 15 seconds that my team has to provision. You already provisioned it without touching the network. Again, just like a VM. Look, the virtual network is only using the existing physical network as an IP backbone. Provisioning network services and software synchronize the underlying network. There's no VLAN, ACL, or firewall configuration changes. Your team gets away from tactical change management and gets back to the real stuff. Network design, capacity planning, and traffic engineering. He's not sold yet. So you're talking about an overlay. What about troubleshooting? I lose all kinds of visibility. Nope. Think about it. Most troubleshooting is caused by manual config mistakes. Automatic provisioning fixes that. And if we find a connectivity problem, we'll actually have more detail about the connected hypervisors. We'll troubleshoot the same way we do now, but faster. So he says, okay, but what about performance and scale? There's no way software networks deliver the same performance as hardware. No, I already tested it. Turns out every hypervisor already has a vSwitch, so there's very little overhead, and I can saturate 10 gig links coming out of the server. In terms of scale, a single scale-out controller supports over 100,000 VMs and over 10,000 virtual networks. Well, that should cover us for a while. Now I can tell his gears are spinning. He says, wow, decoupling from network hardware and vendor-specific architecture could give us a ton of flexibility. That's true, but we don't have to upgrade our hardware. NSX works on our existing gear. It works on any hypervisor with any cloud management platform. And the best part is it works with our existing apps, unmodified. Right then, the CEO pops in and asks if we've looked into network virtualization yet. And Adam's the one who says, yeah, right here. Check this out. So you might want to check it out for yourself.
Welcome back. We are
No, that's not.
continuing our discussion of the history of
Okay, I don't expect you to basically understand every detail he said in this video. I had to watch a couple of times to understand everything he said. But you get a first idea of what network virtualization is, and he pointed some things that are interesting. He said that it makes the provision of networks easier. You don't have to do manual configurations, you do more automatic configurations. You focus on the more high-level management of the network, then on the low-level configuration. And this low-level configuration is one of the problems with networks today, because you don't have good management interfaces. You have often to configure through the command line interface and enter commands one by one. And it's pretty much like programming in assembly when you configure a network. And that's what they describe here as the key benefit, one of the key benefits of network virtualization. Okay, so you can watch this video again if you want. Who knows where to find the videos? Okay. It's basically, you have to Google for me. It's on YouTube. Google for my profile, and I have a I think it's called a playlist with the course videos. Okay. Good. Any questions on the video?
Not on the video, but on the scene over here.
On the video.
All the virtual machines work together, and they provide the result, and they send it to the gateway of the virtual switch, and he's the capable to send it back to the rest of the world.
Which way gateway?
How all these switches cooperate to...
They're managed by a central controller.
Yes, but I mean, where does the information come out from? Is someone of those switches specific to do this job?
You mean it comes out of the data center?
Yes, do all those virtual machines cooperate somehow, and there is just one switch that sends the information out in the rest of the world, or every switch?
Every virtual switch is attached to a physical switch. Okay, and let's go here to see. So this is Open vSwitch, and I don't know, yeah. So this is inside the host. You have one virtual switch per server. Okay. You know, a rack can have how many? 24 servers? I don't know the exact number. And you have one virtual switch per server. And inside the server you have multiple virtual machines. But every virtual switch is attached to the physical network. because it's attached to to one physical interface, the physical interface of the server.
In the video, there was a part where it described the network, and it said that it uses the existing physical network, but then he has drew a line above the physical network, connecting server to server directly. I did not understand how that works exactly. I mean, it has to pass through the physical network.
Precisely. So I think that's a good question, Kali. At that point, he speaks about essentially an overlay network.
Okay.
And this relates to what we discussed print. So with abstraction, what he means is that we hide, that we build a virtual overlay network, and we hide away the physical network.
Okay. So we use the physical network as expected, but even the administrator doesn't understand that, doesn't see the traffic. The traffic can be seen if we measure the network, but I mean, the switches and all that stuff, it's hidden.
The switches are hidden from the tenants. The virtual network doesn't see only the physical network sees the switches.
If I trace route,
You won't see them.
I don't.
No.
Okay.
Anyway, a switch is not.
Even the hops.
Only routers are visible in.
Yes, the switches are not, but to make efficient load balancing, we need routers as well, if I'm correct.
You can do it with switches too.
Okay, so I don't.
Okay. Let's sum up this part. Okay, so I mentioned vSwitch is the de facto software that is used for virtual switches. It's open source, supports many hypervisors, and used in many different software. Stack probably here. And it comes with Linux kernel by default. You don't need to install it on Linux. Okay, that's the architecture of vSwitch. We have an external controller that speaks OpenFlow, as you know. Then we have on the switch some part that runs on the user space, that is the management part. And we have some part that runs on the kernel space, that does the actual switching. Okay. And sometimes if we have a miss here, like we don't have a table hit here on the kernel, we could have some rules stored in the management part on here. So there is an intermediate layer between the switch and the controller that essentially creates a 3-level hierarchy instead of a 2-level hierarchy. Okay, so I talked about virtual switches, but of course virtual switches, on the other hand, we have to keep in mind they have their limitations. Usually they cannot be as fast and as efficient as the hardware. The throughput and latency, it's not as good, although today virtual switches are very highly optimized and they can do like 10 gigabit switching. And they cannot use all the features of the hardware. That's like if the hardware has some smart features for load balancing and things like that, they cannot always use them. Okay, let's take a break now and we continue. Okay. Let's start. So what about the first one, simplified management?
Yes.
Okay. Resource sharing. Good, I agree. Hardware, software, vendor choice.
Yes.
I would say
No?
no. Maybe probably for the hardware choice. Software is easy to choose between, but I'm not sure. Could you choose between hardware components?
Yes, because you can move like the software to different hardware, like the same software to different hardware. If you watch the video again, he makes this point at the end, like at the very end, he discusses this. Network experimentation, network isolation, increase resource utilization, fault recovery.
Yes.
Okay, right. So it's all yes, basically. It's all yes. Who can tell me? Who can explain me fault recovery? Why? Yes.
In case have the log files that actually full information about what's happening there, what actually made a fault.
Right, but not only that.
If you avoid the manual configuration on each router and you simplify your management, then you can easily debug if you can easily manage a network, you can easily find where a fault is.
True. That's also correct. I was thinking of another thing. Let's say that some disaster happens. Like basically the network goes down, hardware is destroyed, things like that. What?
Don't you choose for another path when something goes wrong? You go the other way. You don't have to fix this hardware issue.
In other words, how would you call this? Yeah, but in other words, in virtual machine words.
You can load the file, the configuration file in another virtual machine.
That's yeah, fantastic. Migration. Okay, so the same way you migrate a virtual machine, you do network migration. And take a virtual network, migrate it in another. Any question? Any?
Talk about resource sharing a little bit. Analyze it.
Like this is
Better is a benefit of network virtualization and not of a single network that is not visualized. Why should we go for the V network instead of a simple one when we want to get resource sharing?
sometimes some things you can also do it with physical networks too. Here, the idea is that you can pack in the same network multiple virtual networks. For example, some paths that could be different, you could put them like on the same physical link and shut down the other links so as to save some energy, let's say. Okay, so let's move on and let's go to the to the other form of virtualization I left for the end. I call it here flow visor. So before that, network virtualization is a natural extension of cloud computing to the network. And this is the way it is used today in data centers. But also, if you recall from the previous lectures, network virtualization is a solution to the internet ossification problem. Who will remind us what is internet ossification? Michali.
Basically, the internet creates a backbone that can be changed because some structures are old or some others are very frequently used, so we can't change it because everything will collapse, so it's ossification.
Yes, it's especially with respect to the protocols. Some protocols like the IP protocol, BGP, yes.
Would everything collapse if even for 1 second we would reset them with IPv6, for example, and no more IPv4 or something like that? Let's say we find the technology to replace the internet, and there won't be any more a backbone. If we shut down everything for 1 second, will everything collapse? Won't be easily reset?
You mean you won't be any more ossified? Yes. It's hard to coordinate that. I mean, imagine like hundreds of thousands of networks, Pakistani, in like all over the world, like Israeli talking to Palestinians how to set down. Also cultures. It's hard to coordinate that. But it's not only this the problem; it's also the cost, and as well.
Every other structure that there was before doesn't work after the reboot.
And the risk
Fails. The whole system fails.
Okay, so here we see some things we can do when we want to test a research idea we have. And the problem is that it's very difficult to experiment on real networks with new technologies. Existing approaches is simply to design something on a whiteboard and maybe write some code to verify it. What researchers do very often is simulations in simulation platforms. Then we could also build a small prototype. This is called emulation. But in emulation, it's more realistic because you would use actual hardware and you will build a small test bed. But it's a smaller scale. And the problem is that today, one of the problems of researchers is that we cannot experiment with a new idea we have on the real network. We cannot deploy new ideas. So, Flow Visor is a system that was first built to solve this problem. And is a system that enables another form of virtualization that is called slicing. In slicing, you have a physical network, and this on top of this physical network, you build slices of virtual networks. Okay, so these are called slices. And Flow Visor is an SDN technology. It is also called sometimes network hypervisor. So it's a hypervisor for the network. and it isolates the different slices.
Something like a cloud, those slices, since they are above the physical part, is something like a cloud managed.
It doesn't relate to cloud computing, so it's on the physical network. Okay, so let's see how Flow Visor works. Assume here that we have a data path. We use OpenFlow to control these switches. Flow Visor sits between the controller and the switch. Okay. When we have a new packet and we don't have a rule for this, we will send a packet in, and the packet in will go to the Flow Visor instead of the controller. Then the Flow Visor sees who is responsible for this packet. So it has a number of policies which basically identify who controls this packet. And the packet in then is forwarded to the appropriate controller. Okay. The controller then sends back the flow mode with the rule that we want to apply. And the rule is eventually, after we do another policy check, is eventually applied to the switch. This allows to have multiple controllers on the same network. And essentially, each of these controllers, we say that it controls a slice of the network.
Who does the policy check, since the only controllers are the one who contact the Flow Visor? Don't we need a general controller to know and direct the flow modes? For example, let's say Alice installs a flow rule, but it's not a flow rule to be considered allowed. Who will say that?
Flow Visor does the policy check.
So Flow Visor is a controller as well.
It's not exactly a controller. It's a network hypervisor that also enforces isolation.
Who controls Flow Visor?
The administrator. So the policy limits the slice resources. The flow space is a concept that describes the packets that are associated with each slice. This is called the flow space. In addition, we could have policies about the bandwidth, the number of rules that each controller will install in the table, the CPU power it will use, and so on. So let's see here an example of the flow space. Assume that we have one dimension for each packet field. For simplicity here I only show 3 dimensions, but this could be more than 3. And assume that the packets that have IP addresses in this range, MAC addresses in this range, and any TCP port number are controlled by, I don't know what color is this, the Kian controller. Okay, so this is called a slice of the flow space. So we take the set of packets and we slice them up, we separate them, and we give different areas to different controllers. Does this make sense?
For developers make controllers, limitations about which rule you can use. Because if any packet from port, I don't know, number 3, for some reason, use some kind of packets that actually should be controlled from other controllers. So
correct, Alex. I think the job of the controller of the flow visor here is, if you send a rule like that, is that it will change the rule so that it's only applicable to your space. Any other questions? Sava, sure.
My question, good answer.
Okay, so one of the first SDN networks was set up on Stanford by the creators of OpenFlow. Yes. Okay, sorry. So one of the first OpenFlow networks was set up on Stanford by the creators of OpenFlow. Here are the information. This is a picture of the SDN network. It was initially using 15 switches. Over here is a link with different applications they build on top of the network. So in this network, yes. Software. So what was cool here is that they built slices of the network, of the real network of the university, and they gave them to students to do whatever they wanted with them on their own slice. Of course, they put limits so that if you do something nasty, drop all the packets. This affects only the traffic that is in your slice, but not all the university traffic. But you could still control an entire network of the entire university. However, the problem was that they didn't have real traffic in the student slices, so they came with a scheme to opt in. In this scheme, like if I could create a slice and other users of the network could opt in and send traffic to my slice. And in my slice, I could advertise some smart service that, I do caching and I can, I can prioritize your traffic or something clever. And if you attracted many users, you would have more traffic to experiment with real traffic. Here you see some examples. So slice 1 will handle my HTTP traffic, slice 2 will handle my VoIP traffic, and so on. So starting from Stanford, this was expanded then to a global United States-based test bed that's called Genie. And this is one of the famous test beds with respect to SDN that is used a lot by American universities for experimentation. There is also a similar one in Europe. It's called Ophelia. You see here the interconnection, and also in Brazil. And in fact, I think not last year, 2 years ago, when we ran this course, in one of the exercises, we would give you a slice in Ophelia. As a student, you could control a pan-European network and program it as you like. It was a bonus exercise.
Πότε θα έχουμε και προγραμματίσουμε στον κόσμο.
It's not the next exercise. Okay, so we have some time. Okay, OpenVertex is the next version of FlowVisor. It has some better features like address space virtualization, as well as the ability to do topology aggregation. As you see here, you can create abstract topologies of using OpenVertex. Okay, that's all about FlowVisor. It's simple. It's very simple. It was the first network hypervisor. And it's basically applying the slicing principle of network virtualization. Want to ask something? Okay, so let's clarify now something. What is the difference between network virtualization and software-defined networks? So SDN separates data from control plane and centralizes the control. Correct? Virtual networks separate logical from physical networks. Okay, and they virtualize the network. SDN as a technology can help implement virtual networks. With OpenFlow, it's easy to build virtual networks. However, you don't need OpenFlow to build virtual networks. You can build virtual networks without SDN. So virtual networking and virtual networks is a technology that predates SDN. It's older than SDN. So it's good to know the difference, because sometimes these two concepts are mixed up, while in reality they are two different things, but tightly related. Okay, is it clear? Okay, great. So we have 10 minutes, so So let's see then in the next 10 minutes what is a virtual private network. Okay. So VPNs, networks perceived as being private networks by customers using them, but built over shared infrastructure owned by service provider. So we have two entities. We have the service provider that provides the infrastructure, and we have the customer of the service provider that uses the private network. Okay. So let's see this picture. Here, this is a service provider, and we have a customer that has 1, 2, 3 sites, another customer that has 2 sites. This is an enterprise customer, and we want to build so this could be Starbucks. Has one site here, another site there. And we want to build a private network between the premises of Starbucks. Something like that, for example. Okay, so there are 3 technologies that we will discuss. They are related. The one is to get a list line. I go to the provider and I tell him I need a line, a lambda, an optical circuit, that I will use it exclusively between my sites. This is very expensive, very, very expensive, but I have full control and it's only for me, so I have as much bandwidth as I like.
Can I ask something?
Yes.
Yes, but let's say we have 3 Starbucks places, and we want to build a private network between those 3. But every shop has a provider. It tells us that the providers can't get in that private network since they are the ones who support it. You can have a private network without someone offering you.
Good question. So not everybody can offer this service. Only big service providers, especially in Greece, OTE, very few of them can offer this service, which have infrastructure everywhere. Because they need all the sites need to be in the same. Now globally, it's even harder. Like AT&T, very few like global networks can offer this service.
Yes, but still you are not sure about filtering and the sniffing packets. Why not, if you're a big company, why not put a filter, for example, in your connection? And
these are usually encrypted.
By who?
By you. But yeah, you never know what happens. Okay, let's see the second solution. So this is called customer premise VPN. This is similar with what you do when you connect from home to the university. Now this time the customer, so this guy establishes tunnels between the border routers of the different sites. traffic is encrypted in the tunnels, and it uses a tunneling technology to do the tunnels. This is not really buying a service from the service provider because we can do it from anywhere. So the service providers doesn't treat this package differently. Okay, we can get this for free. However, what's the limitation of this?
The bandwidth, you are limited to the bandwidth of your ISP or any bottleneck.
Correct. So usually VPNs, if you pay the provider, they give you, so they do some quality of service for you. So they give you some bandwidth guarantees or something like that. Any other limitation?
If you set up your VPN server yourself, as not to pay for service, you need to actually be able to maintain this.
Fantastic, yeah. So this is the bravo. Excellent. So the other problem is that you need to maintain and set up the server yourself. So you need the technical expertise. So indeed, if you are Starbucks, you might know how to make coffees, but not VPN servers. Okay. So and there is an intermediate solution that's called network-based VPNs. So in the network-based VPNs, these are also called layer 3 VPNs. We have again a tunnel that runs from the router of the service provider to the router of the service provider again, from here to there. The customer doesn't need to do anything special. The traffic of the customer comes here, and then it enters a tunnel that goes from here to there or from here to there. Now, this doesn't require technical expertise from the customer. It doesn't require a list line to be used entirely by you. You can share a line with also other customers here. So it's cheaper than the first solution. Okay. VPNs, let me tell you, like to big organizations, it's a very large portion of their revenues. They make a lot of money out of it just by interconnecting enterprise customers. So it's important business for them. Yes?
Can we just SSH? Do we have to create a VPN? Can we just make a server and SSH to it?
No, this layer 3 technology. It works on layer 3, not SSH layer 5.
Why not do that? Why would we use VPN instead of anything else? Why should we discuss about VPN? What's the good part of VPN?
Okay, so let's see here. So, by the way, here you see how tunneling works. Okay, you add a header to do the tunneling, you encapsulate and decapsulate at the end of the tunnel, and you do the routing in between based on the new header. So why VPNs? Privacy. The traffic between your sites is encrypted. Security, again. So it's useful for mobility if you have someone that connects from home, for example. So also the cost is good compared to leased lines, smaller costs. Let me add here there exist many types of VPN technologies. So here you can see many different, if you want to dig deeper, you will find many more information. And also it also creates a virtual network that provides abstraction and it's easier to manage. Okay, so let me sum up today. So we discussed about net virtualization. We saw in the beginning that with network virtualization we can mean many different things. Some things that are new and that have emerged the last few years, like data center network virtualization and slicing. These are very new, as well as more traditional technologies like VPNs, VLANs, and so on. So we talked about these two types of network virtualization, and at the end we also talked a little bit about VPNs, so that we have a more complete topic. Okay, so that's for today. Thank you.